Today I will be sharing with you my process of making this Minecraft flower pot. So I will be sharing with you the thought process, the printing process, the problems that I faced and how I decided to overcome it in order to make this product. Right, so I do have a list of the things that I want to say and I'll just go through it one by one. The first thing on the list is why I wanted to make it. I have 3 months of hospitalization leave. Can't really do anything while I am handicapped. So why not just use that little engineering brain of mine to make something fun? Which is why I decided to make the Minecraft flower pot. Some design consideration that I have for myself is, firstly, I can't use templates. Now obviously I want to utilize my time as much as possible. I just want to kill time. So what is the point of just going online to find templates that are already made, models that are already existing, and just print it from there? It's no use. I'm not really using my engineering brain. I'm just using my 3D printer. That's it. So I told myself I have to make this from scratch. Now just a disclaimer, my flower pot may look very similar to other models out there that people originally made themselves. And I think that's normal because we all take our reference from that one same place, which is the Minecraft game itself. But I can assure you, from start to end, my idea is 100% original. No, I didn't take anyone's design. I didn't take reference from it. The only thing I took reference from is, like I said, the game itself. Alright, so let's dive into the very first, which is the thought process. So obviously I do need a reference. So I hop onto the game and got myself models of the flower pot and the flower itself. You might see that I did some sketching of numbers. So the flower pot have different shades. So I decided to just cut the flower pot into grids, and for each shade I just give them one number. So let's say if these 3 blocks are the same shade, I'm just going to call them shade number 4, and I'll just write it down. The reason why I'm doing this is because I want to make grooves. So now this brings me to my first thought process, which is basically the grooves. You can see that it is a 3D flower pot. It's not 2D, it's not flat. There is protruding elements to it. It's very easy to make a flat block of rectangle, a box that's hollowed out. Very simple. But it takes a little bit more effort to add the details, and that is what I wanted. I wanted details. I wanted to make my life harder, to be honest. So I added grooves. The next thing I want to cover on is the dirt. The dirt is a separate piece. I'm just gonna pull it out. You know what, I shouldn't. But anyway, inside the flower pot, you can see a different shade of brown. That's basically the dirt. Same thing, it do have a protruding element to it, the 3D effect. Whereas something you'll notice that my build, they actually have a lot of holes, a lot of joints, because I wanted to keep this glue free. I wanted it to be like Legos, where you can just snap the pieces together. Unfortunately, I had to glue some stuff together due to some mishap along the way. I'll talk more about it when I'm talking about the flower stem. But yeah, for this dirt, it's actually friction tight into this flower pot. Right, next I'm going to talk about is the design of the flower head. So first thing first, choosing the flower. So I decided to go for orange tulip instead of the OG poppy or dandelion, the red and the yellow flower. Making the head, it was not as smooth as I thought it would be. I started off with a very flat design like always. And from there I just experimented, I prototyped, I designed in the SketchUp software. In the end I finalized with this design where the middle is the thickened part. Initially I wanted this to be 2D, completely flat. Not like this kind of flat, but like individual stem is flat. Like you don't have the protruding outer green. I didn't want that initially, but since my pot, my dirt, my flower head was already going to be 3D, and like I said, I just wanted to kill time and just really put myself through the extra pressure and effort. I just thought, at the end of the day, why not just make this 3D as well? So I did exactly that. Right, moving on to the printing process. First thing that I had to arrive to a decision was the flower pot. I wanted this to be one solid build. What I mean by that is, you can see right now there are grooves, you can see the lines. I didn't want that line, I wanted this to be completely clean. As you can see from the bottom, I didn't want any of this, I wanted it to be smooth. But unfortunately, I am not a big fan of printing overnight. I just hate the idea of it, to leave something unattended, unsupervised. I like to check on my build every 10 minutes, 15 minutes or so. So I have, not say no choice, but in order to compensate for the paranoia, I had to slice this into different parts and print the parts individually. The next thing I want to talk about on the printing process is actually the stem. Well, 3D printers, they can print really flawless, clean, smooth surface print. However, the moment you add a support, or the moment you have to print something that is not on the product itself, there's going to be blemishes, there's going to be flaws, there's going to be uneven surfaces, you know, the roughness that you wish you didn't have, and if you want to remove it, you have to put in the extra effort to sand it away. So I didn't want support for my stem. You can see that both sides, or rather all sides, there is uneven surfaces. And I wanted to minimize support as much as possible, which is why, I don't know if actually I can show you here. You can't really, but basically what I did was, each side of the stem, or not say each side, for all the stem, I made sure that one side was completely flat. So I didn't have to print support, the flat part was going to be the one touching the bed. And yeah, no support. And what I had to do to compensate for that is basically to print the little cubes individually, and then I just paste them on the stem. So that is how I got both sides to be 3D without having the need to print support. Alright, so now moving on to the problems that I face. So the first one is a very common 3D printing problems, is basically warping. So for those of you who are new to 3D printing, warping is basically when the bottom foundation of your build doesn't want to stick to the bed, which in the end just get pulled up and doesn't form a flat surface. So you can somewhat see there is it's not straight basically. I don't know if you can see, but there are like grooves here. You can see the groove inside. It's due to the warping. Oh yeah, you can see there's a warping over here, and I just filled it up with putty. It wasn't that crucial for the flower pot, but I wanted my stem to be flawless. So in the end, my solution was to do bed support, which is the brim. New users out there, there's 3 kind of support you can print around your 3D print, which is basically rough, which is I feel the worst. You are essentially just printing a thick layer of plastic right below your entire build. So if I want to print this, there'll be an extra plastic just right there. So rough is, I just feel it's a waste of material. Next will be skirt, which is essentially just drawing the perimeter of your build. So the skirt will just draw like a cross sign, the plus sign around it. Pretty much, it does nothing, but I guess it just indicates the perimeter. So anything within that perimeter will be where your product is. Brim is the useful one. Brim is basically where it prints a perimeter just like skirt, but this perimeter actually is attached to your build. So it will actually like be connected to your build, and somehow, some way, it is a wonderful, excellent solution to prevent warping. Alright, next problem I face is tolerances. Every single 3D print will have this issue, no matter how accurate it is. Unless somehow you manage to find a way of just printing it flawlessly to your exact measurements, then good for you. One or two good example is the dirt and the base. Because I had to print this 4 walls individually, obviously there's going to be a lot of misalignment, especially with the warping and everything. Alright, and then now come to the problem that I've been pushing away since the start of the video, is why I have to glue the stem together. It's kind of a sad story, not say sad, but as an engineer, you know, it's a mistake that is easily solvable at the start of your prototyping stage. Except I kind of just speed run my prototyping stage, so it didn't occur to me. So first thing first, Like I said, I printed one side to be flat. And just nice, I printed all the left side to be flat. Basically, one of the, I just tried the fitting by putting them into their individual slots, and they actually connect. But that's the problem, because one side is flat. After gluing the individual cubes, the squares, to the flat surface to make all the surface 3D, they were interrupting each other, they were colliding. One good example is, you can see that the dark surface here and here will actually kiss each other if I were to put the two pieces together. And because of that, it will cause a gap, because they can't compromise. You can't squeeze plastic, you can't compress plastic. I just used the pen knife and just cut a 45-degree on each of the little extruding surface so that it can fit nicely. And I just used glue to paste it down, cause some parts were still kind of pushing each other, and I just forced them to be together, which is why I ended up using glue. Sadly, I can't really enjoy the Lego aspect of it. Right, so that's everything on the list that I wish to share. It turned out good. I'm satisfied. Unfortunately, I actually finished this project faster than I thought I would take to finish. I actually gave myself like a 1 week, 2 week timeline because I wanted to enjoy the process. Halfway through, I didn't enjoy the process because of mainly the 3D printer. It was just on my nerves the whole time because it just kept failing and failing and failing, and then I turned out it's just because of the Z offset. It wasn't just the best, it wasn't calibrated. My dad had to come in and he just turned a few knobs and everything would work out, and I'm like, bruh. That's a problem with engineering, the problem is always simpler than it seems. But yeah, whatever, we overthink. Some other problems is I made all the joints smaller than the hole. For example, if this hole is 5 mm in radius, I made this 4.8 mm in radius. I wanted it to be somewhat of a perfect fit, so I don't need to add. I don't need to glue. I don't need to add extra thing. Like I said, Legos. Fortunately, it's a little bit wobbly. So I just decided to stuff a toothpick inside. Not say stuff, but I'll just leave it there. Okay. Push that thing in, and then I just put the flower on top. So this is my Minecraft flower pot. So I hope you all enjoy this little process of me just reflecting on my design.